Hi everyone. In this given problem statement, we are going to solve longest increasing subsequence. We are given an integer array, return the length of the longest strictly increasing subsequence. So let us take this example of 0, 1, 0, 3, 2, 3. So if we are at 1, right? So what would be longest strictly increasing subsequence? So it would be at 1. Is 1 also strictly increasing? It is increasing. Is 0 strictly increasing? No. And this is a subsequence. It is not a sequence. So you need to understand, right? We can skip some words in between to form the longest increasing subsequence. So 0, 1, then 2 and 3. So one sequence would be 0, 1, 2 and 3 starting from this value. Then from 1, what would be longest strictly increasing subsequence? It would be 1, then 2 and 3, 1, 2 and 3. Then from 0, it would be 2 and 3, 0, 2, 3. 3 cannot be forming any longest strictly increasing sequence because 3 is the largest number and the other would be 2 and 3. So this would be the values, and from the looks of it, right, to solve it you would require big O of n square time complexity, which might not be very efficient to calculate this type of problem. So a better way would be a dynamic solution. So this type of problem, right, we call it longest increasing sequence, or LIS. So here, right, can I do it with the help of recursive approach? So let us take another example. Let us take a small example. 1, 2, 3, 5 and 4. So here, right, initially, right, in which directions we can go. So from the starting, I can take 1, I can take 2, I can take 3, I can take 5 and I can take 4. Then from 1, I can again, and whenever you're taking 1, right, we are going to add 1 plus 1 equal to 2. So here, right, I can take 2, I can take 3, I can take 5, I can take 4. From 2, I can take 3, I can take 5, I can take 4. From 3, I can take 5, I can take 4. Then from 5, right, I cannot take 4 because 4 would not be strictly increasing, right? So here, right, the longest increasing subsequence would be, so 1 plus 2 would be 3, 1 plus 3 would be 4. So it would be the 4. And here, right, you have to compute all the values again and again, right? So because of that, right, we have to use recursion plus memoization. So how to solve it, right? We have to take a base condition. So in this type of cases, let's say I call DFS and let me call it solve. And the index and I can pass in the prev. The value would be like if index equal to n, which would be the length of the array, then I can say return 0. And here, right, with the help of dp we have to store it. So I can say if here it is an 1D, so we do not require the prev value. So even if, say, if index in dp, so I can say return dp whatever the value that is stored, index. Now the tricky part, right? So I can say for I in range, it would be whatever index that we are at, index plus 1 to n. And here, right, we are going to call. So initially, right, the max length we can initialize at 0. And here, right, I can say max length equal to max length plus, because also we need to check one more thing, which I forgot to add. We have to check, right, the value that we are going to take, whether it is greater than the previous value. So nums of I, is it greater than previous value? So in that case, right, it would be 1 plus solve, and here, right, it would be I, and instead of previous value, right, because now the previous value would be nums of I. Okay, but in case it's not the maximum, then we can simply call the solve value. We can pass in the I, but instead of nums of I, we have to pass in previous value, which was the existing one, because it didn't find. Means let us take this example, right? Or let us take example, instead of 2, right, here would be again 1, right? We are going to skip the 1. Now, because we are skipping the 1, right, our previous value won't become this 1. Our previous value will still remain 2. So that is the idea, and we can calculate the sum. There is other way also of doing it. We can create an array and store the values. I will probably show both of the approaches for you guys, but you can decide, right? There will be a tabulation method also. So whatever we do, right, our overall time complexity would become big of n square, and this would be the most efficient solution. But there would be another approach with the help of bisect and other things, which maybe I will create a documentation for you if you want to deep dive, where we can improve our time complexity from big of n squared to n log n, and that would be a little bit tricky for most people, I would suggest. So I think for most interview, right, like if you're able to do the recursive or tabulation method of longest increasing subsequence, I think that should be efficient enough. Now let us jump to the Python solution. Hi, the first thing that we need to do, right, we need to initialize our n. N is going to be length of our nums. And then for dynamic programming, we can assign dp, which is going to be a dictionary. Then let me create the function called solve, where we are going to pass in the index and the previous value, the base condition, right? So if index is equal to n, in that case I can say return 0. If we have already computed the index and it is in the dp or our hash set, then we can take the value and return it. So dp of index. Now the thing is, for I in range, and we have to pass in the value from index to n, and I can say max length. So initial max length would be 0, so it would be max length equal to max of max length, and we are going to pass in solve. Oh, because we already found a greater value, right? So it would be if nums of I is greater than the previous value. So in that case, max length would be max length plus solve I, and the value would be nums of I, because I have computed that. And I can say dp of index is going to be max length, and I can return dp of index, and let me call the function. So return solve, the initial index would be 0, and initial value we are going to pass in float of minus infinity, because whatever the value it would be, right, it would create, the first value would create a increasing sequence, right? So the value before that, right, you have to make sure it is negative infinity, so that whatever value that is present in the first index is always counted as 1. As you could see, the code is running successfully. Let me submit the code. As you could see, the time complexity big of n square. Can we optimize it? And to optimize it, right, we can do through tabulation method. So what I can do, I can say dp, and I can initialize with 1 multiplied by n, and here I can say for I in range n, for j in range of I, if nums of I is greater than nums of j, and instead of, okay, let me just give it dp only. So dp of I is going to be max of dp of I comma 1 plus dp of j, and I can say return max dp, whatever value would be longer. And you can just draw the tabulation diagram to get the formula, and it should work. Let me submit the code. As you could see, it's waiting 38.31% submission, which is efficient, but it has a lot of scope for improvement. So those can be done, right, with the help of bisect, and there are other approaches of doing it. But for the most interviews, right, they should be efficient enough. That's all for this video. See you in the next one.